As we start to head further out in the solar system, we enter the realm of the giants. And the first one we encounter is the biggest giant of all, Jupiter. A mysterious banded world shrouded in clouds and violent storms. Jupiter was named after the Roman god of all gods, and it has been known since the ancient times. It is the third brightest object in the night sky after Venus and the Moon. Jupiter is the fifth planet from the Sun, and it orbits 778 million kilometers from the Sun, which is about 5 times the distance between the Earth and the Sun. And it takes about 12 years for it to complete one orbit around the Sun. Jupiter has the fastest rotation of any planet in the solar system. It completes a full rotation on its axis every 9 hours and 55 minutes. And this fast rotation almost squashes the planet into a sort of bulge. Its diameter at the equator is actually slightly larger than its pole-to-pole diameter. As we all know, it's the biggest planet in the solar system, and its diameter is about 139,000 kilometers. That means it's over 11 times the size of Earth. Jupiter is also by far the most massive planet in the solar system. It is 320 times more massive than the Earth, and that means it has an incredible gravitational pull, over 2.5 times the gravitational pull of Earth. So say for example, if you're a 100 kilogram person on Earth and you stand on Jupiter, you would weigh approximately 250 kilograms on Jupiter. The cloud tops of Jupiter are made up of 89% of hydrogen, 10% of helium, and trace amounts of other gases. And now the cloud tops of Jupiter are very colourful indeed. You have so many different bands and colours and everything, and they are made really evident in these pictures here taken by the Voyager spacecraft in the 70s, but even more so recently by the Juno spacecraft that arrived at Jupiter in 2016. And the main feature of the atmosphere, of course, that we see here is the Great Red Spot. And as far as we know, this is a permanent feature of the planet. You see all these bands and you see all it changing all the time. It's such a turbulent atmosphere. It's a great mystery. How on earth does a Great Red Spot keep going amidst all the turbulence in the atmosphere? There are several white spots that appear near to the Great Red Spot as well. They come and go and they merge and they come apart again. It's so interesting and weird, and it seems like the Great Red Spot may just be a culmination of different storms that seem to just survive. The cloud tops of Jupiter are mesmerizing to look at. One of the great mysteries about Jupiter has been its interior, and Jupiter doesn't really seem to be giving up its secrets too easily. Either it's gas all the way through to the center, and eventually the pressure of the gas sort of transforms the hydrogen into like a metallic liquid sort of thing, and then even further down it goes into a solid. To me, that seems pretty likely, but what we don't know is if Jupiter has a rocky core or not. Did Jupiter start out as a rocky world before it got transformed into the gas giant we see today? Who knows? Being such a big planet means Jupiter also has a big magnetosphere, and it's powerful as well, the most powerful in the solar system besides the sun's. And it's so big that if we could see it with our own eyes in the night sky, it would be larger than the full moon. It stretches way out behind the planet and creates the most energetic aurorae in the solar system. It is so powerful that it creates its own radiation belts around the planet, which are incredibly dangerous to passing spacecraft. The radiation belts are in like a ring around the planet, and they envelop most of the moons, and Io, the closest moon to Jupiter, is in probably the most dangerous part of the radiation belts. It is being cooked by radiation. And it's incredibly dangerous to passing spacecraft as well. If a spacecraft isn't fully prepared to go through the radiation belts of Jupiter, then it can scramble the computers on board. And that's pretty much what happened to the first spacecraft that visited Jupiter. Pioneer 10 didn't send much data back because its computers were in effect being cooked by the radiation from Jupiter. Speaking of powerful things about Jupiter, the planet has thunder and lightning, and we know this from data from the Juno spacecraft, and it is 10,000 times more powerful than lightning on Earth. It is truly energetic. Now, Jupiter has rings. We can see from this in Space Engine that when the sun goes behind, we can see the rings, and they are extraordinarily faint. And this is because they're only made up of a little bit of dust and not many large asteroids like the rings of Saturn, which we'll get onto in the next video. But the rings are there. They are fairly nondescript rings. I mean, I don't really know a lot about them myself. Now, as you have been seeing by me flying around in Space Engine, Jupiter has a lot of moons. In fact, it has 95 in total as of recording this video. And the big four moons, Io, Europa, Ganymede, and Callisto, will be covered in future videos because they are incredibly interesting. The rest of the moons are kind of a bit boring. They're kind of just regular space rocks. They're captured asteroids mostly. The big four are called the Galilean moons, and that's because they were discovered by Galileo Galilei in 1610. But of course, as I said, we'll go on to those in a future video. Now, one of the big questions of every planet is, how did it form? And with Jupiter, it is exceptionally important to know how it formed, because with all the models that we make in computer simulations for the birth of the solar system, Jupiter forms first. It is the oldest planet in the solar system. Jupiter has to have formed first because it is well known that gas giants form quicker than rocky planets. If you think about a gas giant, all it has to do is just suck in a load of gas and form it into a sphere, which is a lot easier with gas than it is for rock. If you take a lot of rock and combine it together, it takes a while to form it into a sphere that we see in Earth, Venus, Mars, Mercury, all that. So we think with Jupiter it only took about 5 million years to form, which might sound like a long time, but it really isn't in solar system terms. It's a blink of an eye, really. But we do not think that Jupiter formed where it is today. And why is that? Because there are several anomalies across the solar system that just don't have any answer to them besides this. Now, there is a boundary in the solar system that we call the snow line. It's a boundary where water turns to ice. But what we find in the asteroid belt is that there is a mix of rocky and icy bodies, which should not make sense, because if the asteroid belt is in front of the snow line, then there shouldn't be any icy bodies there. And Mars is also not very dense at all. It's also not very big. It's only 10% the mass of Earth, which shouldn't make sense for a world of its size. And so, when looking at these mysteries using computer models point the finger at Jupiter for these two very strange anomalies. And the reason is, when we look at distant stars and their solar systems, our solar system is not normal. It is far from normal. Having the rocky planets close to the sun and the gas giants further out is a mere coincidence. It is actually very normal indeed for planets like Jupiter and Saturn to be much closer to the star. I'm talking closer than Mercury. We see this so often around other stars, and it becomes clear that our solar system is not normal. And so what we think happened in the solar system's early history is that Jupiter formed, and as soon as it finished forming, it started spiraling towards the Sun. It started going into the inner solar system where Earth, Venus, Mars, they were all forming. And of course Jupiter is so massive that it has a huge gravitational effect on everything near it. And so what it did when it reached the inner solar system is that it threw everything out in its path. Some of them would have been sent into the Sun, others would have been thrown out into the universe, never to return. And this really had a big impact on the planets. Jupiter advanced all the way to the orbit of Mars, and when it threw all those pieces of rock out into the universe, Mars was left with very little to grow itself with. Jupiter threw 99% of all the asteroids' total mass away into the universe. And so that answers the question that I left you on a cliffhanger with in the last video. Why is Mars not as dense as the other planets? There you have it. But you might be asking, did Jupiter stop there? It wouldn't have if it wasn't for Saturn. Now, Saturn forming had a big impact on Jupiter. It too formed in a similar way to Jupiter very quickly, and since it was less massive, it did the same thing as Jupiter. It fell inwards towards the Sun, and more quickly than Jupiter did. Over time, Saturn and Jupiter got into what we call an orbital resonance. Jupiter orbited the Sun exactly twice for every orbit of Saturn, and that meant that every Saturnian year the two would meet in the same place in their orbits over and over again. Through very complicated gravitational interactions, the pair then moved themselves back out again in this gravitational dance, and this is called the grand tack theory. Now, Jupiter still has an absolute vice grip on the asteroid belt today, and its gravity can sometimes send asteroids on a wayward course towards another planet, and that includes Earth. And this is what we think happened 65 million years ago. An asteroid was influenced by Jupiter's gravitational pull, and it sent an asteroid on a collision course with Earth, and this is what wiped out the dinosaurs. But for all its destructive power and throwing asteroids our way, it's also our protector. You see, Jupiter has, of course, a gravitational effect on pretty much anything that goes near it, and for objects coming from the outer reaches of the solar system, it acts as a shield to the inner planets. And this is exactly what happened in 1994, one of the most incredible events that we've witnessed in our solar system's history. In the early 1990s, a comet called Schumacher-Levy 9 had a close encounter with Jupiter. The sheer gravity of Jupiter completely ripped the comet to shreds. It was in a big line of debris. Then when it hit Jupiter in July 1994, it created a spectacular light show, and it was witnessed by several spacecraft, including Galileo, that was on the way to Jupiter at the time. And it captured the moments that these asteroids hit, and they are so bright, and they're hitting on the night side of the planet and creating these huge fireballs, which are equivalent to many millions or even billions of tons of TNT. And when the day side of Jupiter came around again, we noticed these huge bruise marks. They created these brown clouds which showed all the impacts of the comet, and it really does remind you that we are in a dynamic solar system. The solar system is not a peaceful, serene place, and we have violent events like this happening before our eyes, and it really is incredible that we were able to witness that. And that just shows you how powerful Jupiter is, how much influence across the solar system it has. Now, the next time you look at Jupiter in the night sky, take a pause and think for a minute. You are looking at the great sculptor of the solar system. You are looking at the planet that, if it wasn't here, we wouldn't be here. The awesome power of this planet cannot be understated. As violent as it can be, it is our protector, and without it, we would not be here. That is what I want you to think about. Thank you everybody so much again for watching this video. I very much enjoyed talking about Jupiter today. Please leave a like down below if you enjoyed. I hope I changed your perspective about the biggest planet in the solar system. There is so much more to learn about this giant planet that I haven't talked about. I will probably do a follow-up video in the future on this planet, but for now we will be moving on to the next planet in the solar system, the beautiful ring planet Saturn. And until then, I will see you all in the next video. Goodbye everyone. Thank you, a mysterious banded world, shrouded in clouds and all gas straight through, and is a gas giant. Oh, f me.